All right, good morning, good afternoon, rather. We are looking at welcome back to pre-calculus. So we are trying to figure out a system of nonlinear equations. Okay, so we can go back up here and kind of read the problem to us a little bit. So we have a diabetic patient receives emergency insulin injection, but the chart does not indicate the dose. After 1 hour, the insulin concentration in the bloodstream is 44 units per liter. After 4 hours, it is 32 units per liter. Use A of t is equal to A sub 0, e to the negative kt. That's the exponential decay function. We're not requiring you to memorize that for, you should have it memorized, but we're not requiring you to have it memorized for this particular problem. And we're going to determine the initial concentration. Okay, so the idea here is we're going to figure out what A sub 0 is. All right, I wrote down the problems. I didn't spell it right. But here is the original, the model that we're supposed to be using. Okay. And then here we have, after 1 hour, we had 44 units. After 4 hours, we had 32 units. Okay. And we have to figure out like how to solve this thing. We have two equations and two unknowns. That's always the thing you're looking for. So the first thing I'm going to do is I'm going to say that this is 44 e to the k is equal to q sub 0. All I did was multiply both sides by e to the k. Okay, e to the k for this one. Negative 1k plus positive 1k will be 0. E to the 0, of course, is 1. Okay, so we have q sub 0 is equal to 44 e to the k. Here, we're going to do the same thing. We're going to multiply both sides by e to the 4k, e to the 4k. So I have q sub 0 is equal to 32 e to the 4k. All right, and that's what we have for this. Now, I've got q sub 0 is equal to this piece, and q sub 0 is equal to that piece. What do you say we set them equal to each other? So I'm going to say that we have 32 e to the 4k is equal to 44 e to the 1k. All right, and that's what we're doing next here. So what I'm going to do is I'm going to go ahead and say, let's divide both sides by e to the k. So I'm going to multiply by e to the negative k on both sides. Right, when the bases are the same, we add the exponents. We have 32 e to the 4 minus 1. 3k is equal to 44. All right. Now, I'm going to take a logarithm. So what I'm going to do is I'm going to divide both sides by 32. So I have e to the 3k is equal to 44 over 32. All right. That's going to be a decimal. Once we have got this e to the 3k all cleared off, now it's time to take a logarithm. So if I take the natural log of e to the 3k and take the natural log of 44 over 32 on both sides, right? Take the natural log of both sides. Remember your logarithm rules? Where this e to the 3k comes down in front, we could say that 3k is equal to the natural log of 44 over 32. All right, we're going to divide both sides by 3, so I could say k is equal to 1/3 natural log of 44 over 32. And that's going to be my that's going to be my answer for k. So let's go ahead and turn to the calculator for just a moment. So we're going to say, okay, here we go. We need 1 divided by 3 times the natural log. Where's my natural? Actually, I'm going to do it a slightly different way here. We're going to say, where is my natural log? Right there. 44 of 44 divided by 32. Okay, equals. And then we're going to divide the whole thing by 3 or multiply by 1/3. It's the same thing. So divide this thing by 3. Right? And my k is, we're going to go to 4 decimal places, 0.1062. So we can say this is k equals 0.1062. Okay, I've got my helper here. Oh, you can see. Oh, there he goes. Okay, it's almost time for dinner, so he's very excited to be. He needs to be my assistant to make sure that that works. Okay, but there we go with our K. All right. Once we know our K, we still have to figure something out here, right? We still have to figure out what the initial dosage. I mean, the doctor is like, okay, great. The metabolic half-life is going to be, the metabolic rate of decay is going to be this thing. But that doesn't help us because we still need the initial dosage for what's going on here. Okay, so we have to go back into the original equations here. It's up to you as to which one you want to actually deal with. I'm going to go ahead and say I would like Q sub 0, right? Q sub 0 to be equal to E. Well, actually, Q sub 0 is equal to 44 e to the k. Okay, so we have 44 Let's go ahead and erase. So we have 44 e to the 1, because we're only there for 1 hour, 1.1062, and we're going to go ahead and say that. So since 0.1062 is equal to 0.1062, we're going to go ahead and say we need second function ln, second function answer. That's e to the thing we just typed in there. Okay, and we'll see if that does that for us. Nope, didn't like that at all. Okay, so clear that. So we're going to say second function this, second function ln, that's what I wanted. So that'll be the 0.1062 equals, and then say times 44. Okay, and I got 48.927. So we're going to say this 48.93. So 40, what was this thing? 48.93, 48.93. And that'll be our answer. If I just wanted to check something, we could go ahead and say, well, what's the other one say? And that's q sub 0 is equal to 32. Is equal to 32 e to the 3 times 0.1062 and see if that does it. Okay, so we can go back up here. Let's okay, well, we're going to be a little bit off because I didn't save my answer and it's just kind of there in the ether there. So we have 3 times. Now, when you're typing this stuff into the calculator, I would recommend doing the small amounts that you actually need to do for this thing, okay? Because the calculator gets easily confused, or we don't actually type things into the calculator as well. So we're going to go ahead and say that equals, and it will say times 32, knowing that I'm going to be a little bit off. That's okay. And I ended up with 44.006. There's a q sub 0 is equal to 44.006. These are close numbers, and we are very susceptible to round off error when it comes to this. That's why I say at least 4 decimal places, because if it's not that much, it's going to be off. Okay, so that's a reasonably close answer. So we can say, okay, that's probably it, and we'll be okay with that. Okay, so I'm going to say this. Thank you very much for watching. It's a keep problem, and I will see you on the next problem in the next video. Thank you.